Hello and welcome. Today we're diving into the world of Venn diagrams and probability, and I promise it's not as dry as it sounds. Ha! Here's a little joke to start us off. Why did the statistician break up with the Venn diagram? Because it just didn't overlap with their interests. All right, let's get down to business. So grab a pen, get comfy, or just sit back and relax. You can always pause to think if you need to. All right, let's turn to the next page. On this page, we're starting with some key terms to make sure we're all on the same page. First up, referring to point 1, we have a Venn diagram. This is a simple tool for showing relationships between sets or groups of items with something in common, like students in clubs. Imagine two overlapping circles showing who belongs to which group or both. Next, we have a set. A set is a collection of unique items, like a group of students. Here, each circle represents a set. The left circle is the math club and the right circle is the science club. Moving to point 3, we have intersection. This is where two sets overlap, representing students who belong to both clubs. And then the union is the combined area where elements belong to either or both sets. So everyone in either the math club, the science club, or both is part of the union. And lastly, probability. Probability is the likelihood that an event will occur, measured on a scale from 0 to 1. 0 means it's impossible, and 1 means it's guaranteed. Keep these in mind as we go forward. Now let's turn to the next page to break down the components of a Venn diagram. Now on this page, let's go a bit deeper into the parts of a Venn diagram. Looking at the slide, we see two overlapping circles. Referring to point 1 on the left, each circle represents a club, the math club on the left and the science club on the right. These circles act as containers for each group. Point 2, the overlapping area in the middle, is the intersection. This is where students who are in both clubs are represented. For example, if a student is a member of both the math and science clubs, they belong in this middle section. Finally, we have the area outside both circles. This grey area represents students who aren't in either club. It's like the no club zone. Altogether, this setup lets us see the relationships clearly. Who's in only one club, who's in both, and who's in neither. Let's turn to the next page to see how these categories look with actual numbers added to the diagram. Here's the full Venn diagram with numbers showing how students are divided across the categories. Referring to point 1 on the left side of the Venn diagram, we see 30 students in the math club circle who are only in the math club. These students aren't members of the science club, so they're in the blue region on the left. Now, on the right side of the diagram, we see 25 students who are only in the science club. These students are in the red area outside the overlap, meaning they aren't members of the math club. In the purple area, where the circles overlap, we see 10 students who belong to both clubs. These students are in both the math and science clubs. Finally, outside both circles in the grey area, we have 35 students who don't belong to either club. When we add up all these numbers, 30, 25, 10 and 35, we get a total of 100 students. This total is important because it's the base we'll use to calculate probabilities for each category. Now that we understand the layout, let's turn to the next page to go over the notation for probability. On this page, we're talking about the notation P all dots for probability calculations. The P in front stands for probability, and what we put inside the parentheses is the event we're calculating. For example, if we write P of math club, it means the probability that a randomly selected student is in the math club. Similarly, P of science club would represent the probability that a student is in the science club. If we say P of both clubs, we're looking at the probability that a student is in both clubs. And if we say P of neither, it means we're looking for the chance that a student isn't in either club. This notation will help us stay organised. Now let's turn to the next page and jump into our first example calculation. Now here's example 1. We're finding the probability of a student being in only the math club. Referring to the Venn diagram, we can see there are 100 students in total. Out of these, 30 are in only the math club, shown in the blue section on the left side of the diagram, outside the overlapping area. To find the probability, we take the number of students in only math, which is 30, and divide it by the total number of students, which is 100. So 30 over 100 gives us 0.3. That means there's a 30% chance of picking a student who's only in the math club. Let's turn to the next page to find out the probability for students only in the science club. Moving on to example 2, we're calculating the probability of a student being in only the science club. Looking again at the Venn diagram, we see that 25 students are only in the science club, shown in red on the right side of the diagram, outside the overlap. Using the same formula, we take 25 and divide it by 100, which gives us 0.25. So there's a 25% chance of selecting a student who belongs only to the science club. Let's turn to the next page to calculate the probability of selecting a student who is a member of both clubs. In example 3, we're calculating the probability of a student being in both clubs. Referring to the Venn diagram, we see that there are 10 students in the purple overlapping area who are members of both the math and science clubs. To find this probability, we take those 10 students and divide it by the total of 100. This gives us 0.1, so there's a 10% chance of choosing a student who's in both clubs. Let's turn to the next page to see what happens when we calculate probability of a student being in the math club in general, whether or not they're also in science. In example 4, we're calculating the probability of a student being in the math club in general, regardless of whether they're also in science. Referring to the Venn diagram, we see there are 30 students in only math, plus another 10 in both clubs. Adding these two together, we get 40 students in the math club. Dividing 40 by the total of 100 students, we get 0.4. So there's a 40% chance that a student is in the math club, whether or not they're also in science. Let's use the same thinking for the science club on the next page. In example 5, we're calculating the probability of a student being in the science club, regardless of whether they're also in math. Referring to the Venn diagram, we see there are 25 students only in science, plus another 10 who are in both clubs. Adding these up, we get 35 students in the science club. Dividing 35 by 100, this gives us 0.35. So there's a 35% chance of a student being in the science club. Now let's look at the probability of a student being in neither club on the next page. Finally, in example 6, we're calculating the probability of a student being in neither the math club nor the science club. Referring to the Venn diagram, we see that 35 students are outside both circles in the grey area, representing students who aren't in either club. So we take 35 and divide it by the total of 100, which gives us 0.35. That means there's a 35% chance of selecting a student who's in neither club. Now, let's turn to the next page and wrap everything up in our conclusion. In conclusion, today we learned that probability represents the likelihood of an event occurring. We saw that each event was specific, being in the math club, the science club, both clubs, or neither. The Venn diagram helped us visualize these relationships and calculate probabilities for each one. We went through probabilities for students in only the math club, only the science club, both clubs, and neither club. So, remember, probability is a powerful tool for making predictions and informed conclusions based on data. Thanks so much for watching. If you enjoyed this, don't forget to like, subscribe, and hit that notification bell so you don't miss out on more videos. Until next time, keep those probabilities in mind and see you soon. And now for a quick goodbye tune. Probability's fun. Yeah, we're not done. With Venn diagrams and sums, we calculated everyone's odds of being here or there, math or science if you care. Thanks again for watching, and see you next time.